So this is a basic question on SHM, the properties of SHM. And it says for a particle executing SHM along a straight line, match the statements in column 1 with statement in column 2. Note that displacement given in column 1 is to be measured from the mean position. So velocity time graph will be let's just draw all these graphs. So firstly, SHM, simple harmonic motion, it gives us a sinusoidal curve. So the position, let us suppose that the particle starts from the origin, from the mean position, and it goes in the positive direction. So it looks something like this. So this is the xt graph. If you want the velocity time graph as it's given here, well, that's just again a sinusoidal curve, just shifted by pi by 2. So right here you have the velocity time graph looks something like this. It is a sinusoidal curve. So this is S. Acceleration velocity graph maybe. So if you think about it, we know for a fact that if, let's say, the position is represented by amplitude times sine of omega t plus phi, the velocity is represented by omega a cos of omega t plus phi, and the acceleration is negative omega squared a sine of omega t plus phi. Now, if you want to relate the acceleration and velocity, then what you can do is you can divide v by omega and then square it, and you can add this to the square of acceleration divided by omega squared, and this will give you a squared cos squared of this entire angle, let me just call that theta, plus again a squared sine squared theta. And this looks like an ellipse. So you can take this a squared all to the other side. This will give you v divided by a omega squared plus a divided by a omega squared, the entire thing squared, equals 1. This is an ellipse. So ellipse is R. Let's look at the next one. Acceleration displacement graph will be, well, we can just look at from here. We know for a fact that SHM, the basic equation on which we solve all types of SHM problems, is A equals negative omega squared x, and that's a straight line. So this is going to be P. Acceleration time graph will be, well, again, this is just a sinusoidal curve because x is a sinusoidal, and that is being multiplied by a constant that again gives us a sinusoidal curve, either a sine curve or cosine curve, whatever you want to call it. So again, this is going to be S.